In this circuit, we want to find I, the current through this 16 ohm resistor. Now, when I've got an op-amp in a circuit, the first thing I'm going to do is keep track of the op-amp rules. So let me define some voltages at the input terminals. Let's call this VA, and this voltage here, VB, and my op-amp rules say that VA has to be equal to VB. The other thing is that these currents are 0. Might as well draw those to make sure I'm keeping track of things. Now, after that, normally the next step would be to do KCL at the input terminals. So let's do KCL at B. So if I add this current and this current, I should get 0 because there's no current going into the op-amp. So KCL at B says that VB minus 0 volts, if I use this as 0, so there's my ground, VB minus 0 over 4 ohms, plus VB minus, and let me call this V out, which gives me this voltage here, VB minus V out over 12 ohms is equal to 0. Now that gives me one equation, but I have two unknowns. I don't really know what VB is, and I don't know what V out is. So let me try KCL at node A. So if this is 8 volts, VA minus 8 volts over 10 ohms plus this current, which is 0 amps according to the op-amp rules, is equal to 0. So VA is equal to 8 volts. I could see the same thing by noting that the current through this resistor is 0 amps. If this is 0 amps, the voltage difference across the resistor is going to be 0 volts. So VA is going to be 8 volts plus 0 volts, which is just 8 volts. Now I can plug this in for VB here. So making that substitution, I get 8 volts minus 0 volts over 4 ohms plus 8 volts minus V out over 12 ohms is equal to 0. Multiplying through by 12, that's 3 times 8 is 24 volts plus 8 volts is equal to V out. So V out is equal to 32 volts. If V out is equal to 32 volts, I is V out over 16 ohms, which is just Ohm's law across this resistor. So that's 32 volts over 16 ohms, which is 2 amps, which is the answer to our problem. Now, notice that we solved for V out here rather than I directly. It would be really tempting if we want to find a current here to do KCL at this terminal. But that's not really actually a very good idea. Because if we do KCL at this terminal, I'll get V out minus VB over 12 ohms, which is going to be this current, plus I, plus this current here. Remember that we don't know anything about the current out of an op-amp. So this gives us another equation, but it also introduces another unknown, so it doesn't get you anywhere. KCL at the output of an operational amplifier is generally not a useful thing to do unless you're actually finding the current that the op-amp is delivering.